you're still recording it, and you can pick up the missing minutes later. I used to do that while teaching, actually, but that was last semester. I have to be in the building this semester. All right, here's an announcement. Can it see this flyer? Some screen pop up here. What is this? Okay, this is about next week, February 22 to 25. And I gotta remember to keep it in view. There are 8 events showing up next week. They're special events about engineering, computer science, and they're all great. You can present yourself to all these different clubs and so on. But the one I wanted to mention is right here, February 22, a career fair. To make it stand out, I'm going to make it large font. February 22, next week. Career fair. It's from 3 p.m. to 6 p.m. in the Titan Student Union. Okay, so you may say, but I'm not going to graduate for 2 years. I'm not interested in careers yet. Well, I'll wait and do this a year from now or 2 years from now. That's not a wise move. Career fair. It's really recommended, it's really advisable that you walk through the displays and look at the different kind of job announcements, pick up the free literature, shake hands. Well, you shouldn't, in the age of virus, you shouldn't shake hands. Just say good afternoon to the job recruiters and look at the people and see how they're dressed. Do the guys wear neckties actually, who are seriously after a career job? It's educational about what you should expect later if you just visit the place. So now, if you're near graduating, you probably want to go there in all seriousness. So the recommendation is visit it, visit the place, and find out what's expected when you go there for the real serious visit. Find out. Okay. I'm no expert about job placement, but I know a little bit. And from time to time, I'll share with you the little bit that I know about. And that's one. That's an announcement coming up for next Tuesday. I guess it's a week from today, like that. Okay, what else is on the announcement list? The announcement list says, oh, what about our goals? You know, I should tell you that. Goals, Goals. You know, let me switch to dark black. I think that comes through better. And where's the black one? Come on now. Let's try this one. Okay. Actually, my goal is I want all of you to become productive software engineers someplace. But how do we get there? Okay, one is the near-term goal is you each get high score on the midterm. Okay. A little further into the future is you get a high letter grade in the whole course.
Professor, could you move the paper down a bit?
Yes, thanks for reminding me. It's every day I have a hard way to focus it. Yes, you're right. Get a high letter grade in the course. Okay, further into the future is, we want to get you graduated. Get graduated. Okay, and further in the future is, you know what's coming. Pass the technical interview. Technical interview. I don't have room. That's the final of all finals. It's the mother of finals. If you pass that, how do you know if you passed? If once the questioning changes from technical questions to what kind of salary do you expect here, then you know you've made it. You're going to get a job offer, but they're just feeling you out to find out what kind of salary is this person expecting. And that's a whole nother strategy, is to identify, see, the guy has a budget, or lady has a budget, and they won't tell you what that is, but the budget says you can hire somebody, but you can't go over this amount because we can't afford anything higher. You have to somehow feel your way out to get that highest number without going over the guy's budget, and then he'll still hire you. Okay, but anyways, we want you to pass this test. And that's what we're working for in this class. Got it? Okay. This is one little step, is visit the career fair and find out what you can, how those job recruiters think, and what's in their mind when they're interviewing somebody. Okay, I need blank paper. See if I can keep it in focus. That's about the center, more or less. I'm using it instead of a whiteboard on the wall. At my age, I don't want to stand up that often. I don't want to stand up for 2 full hours. So I'm teaching sitting down, and that's better for me. Okay, I'll tell you a story. It was 3 years ago. I guess it was 2019. Okay. There was a short girl enrolled in this course, same class you're taking now, 240. And she didn't talk to me very often. We were in person at the time. And towards the end of the semester, I get an email from her that tells me her story. And she said in the email, she went to a job interview. Went through the malarkey at the beginning about what kind of, somebody from human resources interviews you and asks, what do you like? What are your hobbies? What do you do when you're not thinking about academic stuff? They're feeling out what kind of a person you are. And she said she said the first interview was okay. And then this interviewer gets on the phone and calls somebody back in technology, and this other guy comes forward to the front desk, sits down, and starts interviewing her on technical subjects. And she said, for 20 minutes, this guy asked me questions on Indianness. And did I get the camera mixed up? Let's try to keep it right there. Okay, so I'm reading the email. She says, it went on from Indianness, and then he says, just explain to me everything about Indianness so I understand what it means. So she talked for 10 to 15 minutes on this subject, 10 to 15 minutes. And then he says, you got it. When can we start? When can you start working? My budget is X. Do you accept this? She said, yes. The next day, she sends me this email and says, you know, I just repeated your lecture on Indianness, and that swung the ball. that won the ball game. They gave me a job offer. So it happens different ways in different companies, but you can win. You're up against all this competition from all those other campuses, but you can still win. But you got to prepare early. Just a hint of how it can go. Let's go to the next announcement. Any questions? I should look. Oh, I got to keep it in view. Okay, we're going to spend today all on programming. And what you don't know it, but I'm trying to get my 3 sections of 240 parallel, so they're right at the same place. And we need to do all programming today, so as to bring you in even with the morning class of assembly and the Monday, Wednesday class of assembly. I want to get you all at the same line. So we're going to do programming, and I didn't know where else to start, so I went back to practice exercise number 1, and we're going to walk through it and find out what's needed to complete that one. Some of you may be already completed, but maybe you can pick up some pointers along the way that can help you improve it. Oh, you didn't get the email about the 5 levels of program correctness, program quality. Okay, I should tell you right now. We'll go on. Professional programs. That's 5 stars. Universe. 4 stars. High school, 3 stars. Middle school, 2 stars. Elementary school. Yeah, they teach computers to elementary school kids. 1 star. This is also known as junk level. Okay, so the grading scale is from 1 to 5. Okay. Universe means university, but I didn't want to write university. So I called it the universe of programming. This one is hard to reach, but once you get there, you show the job interviewer samples of your work, you got a strong chance you're going to be employed. Okay, so we're going for the top one. I want you to get employed when you get out of here. Okay, so how do we get there? Programming exercise number 1, practice program. Number 1. Okay, let's imagine that this sheet of paper is the whiteboard, and I'm going to write source code into it, and that will become my source file for assembly. What goes at the top? Okay, there's in this area is professional identification and documentation. You know, I sometimes get distracted. This past weekend, somebody sent me an assembly program. I'm not saying it's from this class. It might have been from one of the others. And said, hey, professor, I'm all done now. Would you check it out and tell me what's good about it? And I opened it up, looked at the source program. There was the programmer's name is not in it. The description of what it is not in it. It isn't, the assignment number is not in it. The due date is not in it. You know what it rated? Elementary level. It was junk. So I responded to that person. You sent me a junk level program. Why don't you clean this mess up? It didn't pass. That's from a university college age person who's supposed to know better. but sent me total junk, and it rates at Elm level. Okay, we're going for high standards. Professional identification. What do you put in there? One is the program has to have a name. Amazing how many programs I get sent my way. They have no name. The program needs to have an author and a contact for the author, contact information. And if you can, it would be suitable to put not a bio, but author's, should we call it status? I am a student, CSUF, major computer science. Something about, a little blurb at the end of your name that says who you are. Author, who are you? Like book authors say, I'm assistant editor at the Orange County Times when I'm not writing books. Okay. The professional identification needs to know the language the program was written in, the date it was first started, the date of last modification. What else is important? How to compile this program. How to execute it program. Where it was developed, platform. What testing did it undergo? It's amazing how nobody sends me a professional program. I just don't get it. They're trying to be unemployed forever. The professional, I got to keep it in view of the camera. That's what they're looking for. They're looking to know if you act like a professional, and they want to read that in there. A big one that's missing all the time is, what is the purpose of this program? It's just the stuff that comes to me is down at the high school level, where they accept anything to be turned in. The purpose is sometimes a complete full sentence. Don't use partial phrases. One full sentence, or maybe 2 or 3 full sentences to describe what is this program supposed to do. And then exceptions. If during testing something doesn't work properly, that's not 100% a deal breaker. It's just something that should be recorded so that the customer knows what to expect. Exceptions, non-functioning features. Okay. Let's see if I got any others. Well, there's some others, like the language it's written in. Some programs are written in 2 or 3 languages. So programming language. And I put platform up here. You got to state whether this is built to run in Max, to compile in Max. That is what a professional looking program looks like at the initial part, the start of the top of the page or pages of source code. Okay. Let's see if they move the paper in the right place. Okay. Got that one? We'll go on. Okay, so after all of that, you leave a few, after the professional identification. It's amazing they don't teach this in 120 class, but apparently they don't. Okay, moving down, you leave a couple of blank lines. That says blank. and you begin the declarative section. Okay, it doesn't have an official name, but you make a name. Declaratives segment. Okay. And there follows a group of, should I say instructions? They're not instructions, they're declarations. You declare functions to be called that are not in this file that I'm writing onto. Functions that will be called from here. Okay, much further down, where we're going to have function calls, we have to name those functions, except in the special case that the function is appended on this in the same file. Then it's not necessary to name them at the top of the program, but here you have to. So examples are ext, ern, scanf. Scanf is a famous function already written, sits in the IO library, and it's not inside this file. Therefore, you make a declaration that says, hey, this is external to this file, but I'm still going to be calling it. Okay. So you do all of them that you think of, and you go back and later and add some extras whenever you need them. Before you know it, you have a list of 10 of these, like strlen. We'll use that in a few minutes. Then somewhere, they don't have to be in that order, but somewhere in this section of declaratives, we declare constants. So I'll make one. Class size. There's too many S's. Class size equals 45. Okay, that's setting a constant called class size to be the integer 45. Let's say array size. Array size equal 100. Okay, so we have a name that represents the constant 100. You already know how to do this stuff. There's an issue with float numbers. They're not so easy. Max price EQU. Here's the problem. This doesn't work. $75.75. The assembler doesn't like decimal numbers with a dot in them, but it does like hex numbers with a dot. So there's a coming lecture where we're going to spend a long time on how to convert a decimal floating point number to a hex number. So you'd have to write it in the form where it says max price EQU 0x 414 8. I'm not going to be able to fit it. I need 16 digits. 75AB 7008. I still don't have 8 digits. I only have 12. I still don't have 16 digits. I only have 12. Okay, we have to do something. A. Okay. That's supposed to be on one line, by the way, but I couldn't fit it. Okay, that's a floating point number, and the assembler will accept that. So we have to go offline and go to a pocket calculator or an online calculator and find out what the hex equivalent is for the floating point number that you want to use in your program. And then that works. So integers are easy, like that. Floating point numbers can be made to be constants, but you have to go do some work in advance to get a base 16 expression for your float number. Any question? Okay. You got the picture. For those recording it, there's your last screenshot. Okay, so what's next? I'm using scratch paper from somebody else. I guess they're having a field trip to the Amazon warehouse. Wasn't that cool? We probably missed it. Okay. Let's go on. One more in that declarative area is the global declaration. There's usually one. 2 or 3 global declarations is weird. It's legal, but it's really weird programming. So after all those constants and externs, then there's a global. And after the word global, you put the name of the program that the name of the function that you're working on currently. So the name of the function could be, what's the name of the function? How about triangle computations? Okay, that's the global statement says this function, whose name is given here, can be called by other functions outside this file that we're working in. Okay, you got it? Let's go to the next section. This next section, right below that, should start. By the way, there should be a few blank lines here. There's a gap to show that you are a structured programming person. And then it says segment. Am I in the middle of the page? Segment dot data. I was asked if it was legal to omit the dot. No, it gets into bad problems if you omit the dot. The dot has to be there. Okay. And in the 2 segments that come after this one, the dot has to be there. Okay, so what we get out of this is the place to declare initialized arrays. Okay, so we need to know a few. Greetings. DB and good morning. For some of you, you've already done this and it sounds repetitious, but see if you can pick up something useful along the way. Okay, so what kind of array did I just build? I just built char, greeting, square brackets, equals, good morning. Quote, semicolon. If this was C++, you would write this part in the red box. But it's not C++, so you write the line just above it. Let's jump to integers. Okay, so scores. Scores, DD. Does that sound right? Yeah, it's got to be right. Okay, scores 47, 93, 86, 60, and 70. Okay, so there's an array of 5 numbers of 32 bits each one. And if this were C++, what would we write? We would write int scores 5 equals 47, 93, 86, 60, and a 70, and a semicolon. C++ uses lots of punctuation. Assembly uses the least of punctuation it can get away with. Okay, so these two are equivalent in their own respective language. But in assembly, you're going to use the one in the black ink. Okay, so what about, we should go one more. Let's use quad words for our numbers. What shall we call this one? We need an array of, no, that doesn't sound good. I don't know. We'll make a counters. Then it's DQ. 990,000. 1,500,000 and 6 million. Okay, there's an array of 3 numbers and they are all long ints. We'll say they're long ints. These are ints. And so what can we get out of this lesson is, am I in the middle of the page? I hope so. We have choices to declare arrays with DB, DW, DD, and DQ. And if you use the first one, each cell of the array equals 1 byte. If you use this one, each cell of the array equals 2 bytes. You know, simple stuff. Each cell of the array equals 4 bytes. And here, each cell of the array is 8 bytes. Now, I've heard that you can make a DO, but I've never done it myself. I can't speak to it. Someday that will exist and it will be a cell where it's 16 bytes. Those will be big numbers in those. Okay, so I'm going to draw a line here. These we'll use throughout this semester. I've used them a lot of times. This one I don't, I've just only read that it's either exists or it's coming. Okay, let me look at the notes. We got that page done. Next page. Yeah, I think we did this. I didn't want to do one with doubles, did I? Okay. You know, that was really funny. The assembler is the one that has the problem with making constants that are floats. See this right here. The assembler has a problem with that. And it makes us, the human, go through some gyrations to come up with the hexadecimal equivalent. But on arrays, it doesn't complain. So here we'll do one of these that shows float numbers. Let's make it prices. Prices, DQ, let's make it $175.86, comma, $2.99, and $140,000 and 1/10,000th of a penny. And now we have an array of floating point numbers, and that works. Okay. That would be the same as declaring type double and prices 3 equals brace 175.86, comma, 2.99, comma, 140,000, 0.00001, and close the brace and put the semicolon at the end of it. So assembly is really just looks like a bunch of translation from C++. If you're good at C++, then you sort of think in the terms of translation. This is C++, and then the one right above it is assembly. Okay. Let's go to the next segment. Any questions? Okay, here's a screenshot for those who are recording the data. Let's go. Let's make it official. Segment .bss. Okay, the official word is these are more arrays, but they have no data. Okay, so you should, by the way, I think you leave a couple blank lines for readability purpose. There's a gap between the last segment and the start of the next segment. So here we're starting the next segment. Okay, how about some quad words? Hours worked. RESQ 7. So there are 7 cells in the array, but none of them have any data. Oh, how would we do that in C++? I'm going to stop doing the C++. I know you're already an expert in C++. Double, hours worked. Bracket 7. There's the same array without any data, but it's now in C++ and C for that matter. How about, oh, here's one we'll need a lot of. Student name. And RESB. What's the long name? 32 characters of data can be stored there. All right, so you can see the pattern developing that we declare these kind of arrays with RESB, RESW, RESD, and RESQ. Same story as before. This is for each cell is 1 byte. Each cell is 2 bytes. Each cell is 4 bytes. Each cell is 8 bytes. And this is a kind of a standard form. The name of the array, the instructional declaration, and then a number that says how many cells are being reserved under the name of this array. Any questions? Okay, good. We'll go on. Okay, you leave a gap. 1 line or 3 lines, it's okay. Leave a gap. We'll start segment text. .text. I don't know why they named that. I would have called it a segment executable, but it's already done. Let's see, I have a note here in my, I wrote lots of handwritten notes for today's class. It says, don't put a underscore in front of user defined names. Now, it's so tacky when somebody does that. Okay, we better handle this mess. Like somebody's going to declare, see, student name reserves 32 bytes. And then they have to do this. Underscore student name reserve 32. That is the height of stupid tackiness. That underscore came from Microsoft some years ago, and it belongs in Microsoft's system programming office, but it doesn't belong in your programs, at least not in the free spirit of Linux. You don't want to be stuck with something that looks like that. It doesn't help any, and it doesn't, I don't know what it does. It just looks bad. There is a rare case in Microsoft MASM, that's MASM, where you have to have a hyphen start because they don't have a main or some other such problem. And that's required for their assembler, but it has nothing to do with our assembler. Okay, so you got the message. It just looks ugly and doesn't reflect well on the programmer to do that. Okay, we're going to get to segment text in just a very short jiffy here, but there's one other issue. Here's the screenshot. Anybody taking a movie of this whole thing? Got the shot. Okay. What is, this is really the height of dumbness. Don't declare arrays of one cell. One cell. Now, I think the SI leader, he likes this or something, but tell him that I said you can't do it. In C++, you would it looks so dumb. Char name 1. That's what it is, one cell. And then you can say to name, but it's at index number 0, you can say B. Okay. But index number 1 and index number 2 and number 3 don't exist. That's all you get. You just get that. That's an array of one cell. And so every semester I get these, I don't know where you get it from. It must come from online someplace. People creating arrays of one cell. My friend's name, reserve bytes 1, or what else? Class scores, 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 reserve, define quad word 83. Under DQ, that's an array of one number. That's all you get. You just get one number. You don't get 3 of them or 10 of them. It's just dumb. Okay. The assembler will accept it and it will process it as an array of one item at slot 0. But whoever does that, if you never do it in C++, why would you do it in assembly? I think it comes from searching online and finding weirdo examples and then following those weird examples without thinking it through. But anyways, now you know, don't do this. Don't do it. Do it. Okay, you can get in an argument with the SI instructor and see if he believes in arrays of one cell. Okay, back to segment text. Segment, am I in the sit on the screen? Segment dot text. Okay. So when you write that, the first thing that comes after it is the name of the function that you're working on, not the whole program. Remember that in the program identification section, to make it professional, you have a name for the entire program, but the entire program may have many multiple files within it. Okay, this is the name of this one file, this one function in one file. How about triangle computation? And you put a colon at the end of it. That's very important. Okay, and then after that, automatically, you make the 16 pushes. So give it a title. Backup general purpose registers. You can use the acronym if you want, registers like such. And then the first two items in this backup section, they have to be push RBP and copy RBP RSP. And then after that, you have the remaining 15 pushes. Push, 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 push. Okay. But those two have to be first in this group. Okay, then they have special role to play. Unfortunately, it takes like an hour's lecture to work through that, but I'll try to give you like the 60-second version of it. In memory, okay, here's memory upside down as normal. Low addresses are down here, high addresses up here because it's high on the page, and somewhere right here is the top of the stack, and so that marked by RSP. There's a back end to that called RBP, and we'll section this off like here, and then this marker place is RBP. And the area in between is called an AR, activation record. So when a function is executing, there's an assignment to that function of its own personal AR. If a function compute hypotenuse, HYPOT, is executing, then the runtime system, part of the operating system itself, allocates space for this function to have variables declared. Whatever it has, some temporary type double, and it's a temp, T-E-M-P. I don't know what it is. But this space is created to hold these variables. And these two registers mark the address of the front end of that AR space and the back end of that AR space. Okay, now this is the quick 60-second version. If this function calls another function, whatever it is, get length, we'll make up a name. Okay. If this calls another function, then the runtime system, in the operating system itself, has to create a new activation record for this one to operate on. It would be like down here. This is the new one. And the old one is just held in suspense, like it's dead, but it's just sitting there. Okay, so if this is the AR for the new guy, these two have to advance ahead. And how do you get, see, this is the position of the old RBP and the new RSP. We want them to become the new RBP and the new RSP. How do you get, do I have purple? It's here. And you want it to get it to here. Well, one is you see where this guy's pointing? He's pointing right here. if you copy RSP into RBP, then RBP is pointing to this place and you've got it in its new position. Okay. That's what's happening here. This is why this is like saving it and backing it up first. And then you override it with its new position, which is at the back end of a new activation record. That's why these two go first, always. Even online on the web where they have all that junk programming, they still get this one right all the time. Otherwise, the function will crash before it completes its execution. Okay, let's go to any questions? Okay. How are we doing? Okay. What comes next? We got through the backup of the registers, and then you're going to use block structured programming, which means kind of like show a block of statements and give each one its own header. So maybe I'll make one for assignment 1. Show welcome message. Okay, and then right under that descriptive header, there's a group with no blank lines. Move RAX 0, move RDI well message, call printf, and then leave a blank line to show that this block has ended and a new block will soon begin. Okay, so then in assignment, it's not really an assignment where you get points, but in the practicing for the midterm, exercise number 1 program says, ask the user for his or her own name. Okay, so you come down from the blank and then you say, prompt user for his/her name. Okay, so then we do it. Move RAX 0, move name prompt. I missed, wrote too fast. Move RDI name prompt. And that about does it. Call printf. Okay, so you leave a blank. And then you give a message and you declare what the next block is going to do. Okay, obtain user's full name. Okay, well, we have an issue. There are 2 possibilities here. Maybe there's some obscure ones I don't know much about, but there's 2 that are in the forefront. Scanf with string type declared, or fgets with no, you don't have to declare the string type for fgets. So I'm going to do fgets because fgets will read the blank space between first and last name. With that all? All right. So you're going to set this up for using fgets. Here goes. Let's move to RDI, comma, the destination array. Let's call it, how about full name? Okay. Now, that's an empty array. It's from the BSS section, and RDI doesn't know how many bytes are in there. So we need to convey a message, convey that information. Our SI, what should it be? Let's say it maxes out at 32. So we put the number 32 in RSI, and then FGETS, that's our goal, needs to know where the information is coming from. Is it from the keyboard or is it from a data file? And that's what you need to tell it next. RDX STDIN brackets. And it's well understood that STDIN, standard input device, is the keyboard. There is a way to alter that, but that's something for another day. That is the keyboard. What else could go there? You could put a file name there, and you could read that information from a file and put it into the destination up here by my finger. But that's not what we're trying to do in the practice exercise number 1. So now I think it's all set up. Call FGETS. Got it? So let's go next. Any questions? Let's go next page. You're still all here. Okay, if you're at home, sitting in a nice comfortable chair, and you're going to go to the refrigerator and get some really nice cold drink, then don't forget to record this. If you're here on campus, you're probably not that comfortable. All right, well, anyways, FGETS does this, and as a comment afterwards, we're going to say, now name is in full name. Okay, but there's a small issue. The small issue is, let me show you how. Can we go divert to other piece of paper? I don't want to mess up the sequence here. Okay. If the user inputs Joe Barnes and presses enter, what gets recorded in the variable, in the array, is everything in view here. Let's write it out. This is name. That's the array. This is the name of the array. So J is in the first, O is in that slot, this slot. Blank space is in that slot. B, A, R, N, S, backslash, not backslash, enter key, and then null character. It gets everything, and it adds the null character for you to indicate in the string data. Okay, so what's wrong? What's wrong is if you output this, it's going to jump to the next line after the output. This one is the ugly one. Okay, that one right there causes problems if you want to output this name as part of a larger sentence. My best friend is Joe Barnes of Fullerton. Well, it will spit out my best friend is Joe Barnes, and then go to the next line and output of Fullerton. We have to take care of this problem. Okay, let's do it right now so you can get it right on the midterm test. Okay, so what was the last page you left off with? just to remind you, screenshot, shoot that one. We called fgets, and now the name is in full name, but it has that extra character in there that's not pleasant. How do we get it? Okay, we're going to go get string length first of all. How do we get string length? Okay, get number. I'm trying to be professional and put a title on every block. Get number of characters in full name. Okay. strlen is a famous function in C++. It tells you how many characters there are from the start of the string up to, but not counting the null character. Okay. Do we still have that one from the past here? Let's count on this one. Okay. So here's the null character where my finger is. It would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. String length will produce the number 10. L-E-N it is the way you spell 10. Okay, and the indexing goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10's out here. Got how it works. Okay, so we're going after this one from assembly. Get the number of characters in. Move. Here we go. Here comes the block. RAX, 0. Move. RDI. Full name. Okay, that's all that string length requires. Okay, call strlen. Where does string length put that number 10 that we're looking for? It puts in RAX. RAX is kind of unpredictable behavior. So we're going to save a good copy. The very next thing we do, R14 RAX. Comment on the side says R14 holds number of chars, like something like that. Okay. That's the end of that block. Now we still haven't fixed that string, that thing called full name, but it's coming now. Let me see if I get this right. It is, okay, full name. R14 is string length plus R14 minus 1 dereferenced, comma, \null move. Okay, got a screenshot of that? Okay. What that means is, I think we counted 10. In the working example, this was a 10. Okay. So it says go by bytes from the start of full name, add 10, subtract 1, and put a null character there. Can we still do this? I'm looking for a red that I can trust. Okay. Before I do that, we'll just say that to see the pattern, we could do this. Full name plus 0 dereferences to Joe, to J. Full name plus 1 dereference takes us to O. Full name plus 2 dereferences to E. And so inside this parentheses, it's going to what the add-on is. We're going to add on 10, but subtract 1, which means 9. Dot, dot, dot. Full name plus 9. Well, here it is. You can just read it off the picture. Full is the disruptive character. It's the new line character. Okay. So what is where did I give the solution? Oh, it's right above us. Here it is. It says go to that disruptive character and make a copy of the null character on top of it, and thereby obliterate it. That's what move does, makes copies. So when that makes a copy, you know what it's done? Right here, this one gets wiped out with \0, and it reads Joe Brown \0 When you go to output this with printf, for instance, printf will output these characters up to, but not including, the first occurrence of \0. It will stop on index number 9, and you won't get a line feed. It won't get a new line when you output this name. So here's the fix. How can I make it show up in green or something? Okay. Any questions? Shouldn't you? Yeah, it is in here. Oh. Hold on. The lights, let me see, subtract 1. Well, it is in the equation. I agree with subtracting 1. It is in here. Did I miss that in the picture diagram?
No, I was just asking if you would subtract 2 instead of 1, so that you can remove the enter key.
Oh,
You fixed it by
okay.
putting the null over the enter key.
Yeah, that's what we do, is we write over the new line with the, we overwrite enter key with the null character. Say, I don't know if my diagram is really clear, but I know this is clear. I looked it up earlier this morning, and I have it in a working program. That's what you do. You take the name of the array, add the number that came from string length, and you have to subtract 1. That will get you exactly positioned on top of the enter key, and then this overrides it there. Okay. Oh, should you subtract 2? No. I've tried that. You won't get the right answer. Let me get another piece of paper. Let's do the example with just Joe, so I don't have so many things to write. Okay. User inputs JOE enter. Okay. Then full name then full name is J O E enter in the string so that sits in an array. Okay, then you ask string length, how big is this? STRLEN, and it puts inside of RAX all the characters up to, but not including where my thumb is covering up the null. So it picks up a 4. But these are indexed 0, 1, 2, 3, 4, 5, 6, and so on. Okay, so then we take string length, full name, I should, for learning arrays, I should explain. Let me write this in assembly and I'll write it in C++, just so you can match the syntax of the two kinds together. So to advance forward into the cells of the array, we add the number to it. Full name plus RAX would be +4. And if you dereference that, what you get is what I'm pointing to, the null character. But copying the null character on top of the null character doesn't gain you anything. There's nothing useful out of that. But if we go from the start of the array and advance, I'm now going to use RAX. That holds the 4, and you subtract 1, you go all the way to 4 and back up to here, and that's the offending character. That is the one that I called ugly. That's the one you want to obliterate like such, and then use a move. No, it's not -2, and it's not +1. It's not +0. It's got to be -1. Try it in your program. You'll get rid of the new line character that's embedded in your array of characters. Oh, I was going to show this in assembly in C++. That would be char full name and it was originally declared like size 32, but you're not using the full array, and so we would say full name at string length, full name parentheses -1 square brackets, and I don't have room to write it, equals \0 quote semicolon. Okay. That's the C++ expression for all the work I did up here. We had to get that string length into here. So yeah, there's a good learning lesson here. Let's do it several. About indexing in the two kinds of arrays. In C++, if you want to go to an index, like the third character, it's full name, and then 3 is your index number. And then you're at 1 character. In assembly, it's full name +3, and you put the brackets around the whole thing. And then you're at the same place in the array as the C++ version. Okay. Just keep in mind, you don't put brackets around the number individually. the syntax shows that you kind of add the number to the name and then put brackets around the whole thing. Now you know. Okay, any question? Let's go on, class. Where are we on time? We're at 3:40. Boy, that went fast. Okay, we got 10 minutes. We got to do something. My notes say, ask the user to input 3 numbers in one operation. Input a side, and an angle. Okay. This will probably be the last one we get done today. Okay, then you're gonna be caught up with my other 2 sections, and I can move all 3 of you ahead to the same material at the same time. This one needs scanf. Okay, so a new block. Obtain from user 2 sides, 2 side links and angle and angle. Okay. Okay, this calls for scanf, and we need a format for this. Okay, the form. This goes way back to the .data segment. Let's put it in red so we know it doesn't belong here in the .text segment, but somewhere else. So we'll call it the 3 float input. And that's the DB quote percent LF percent LF percent LF quote 0. Okay, so we got 3 numbers lined up for us, and now it's our job to we're going to call scanf, and we'll probably run out of class time. I'm in a classroom where another group of students are going to possibly come in here, but we'll finish this. Okay, so here starts, there's the block title up there in black. Okay, move RAX 3. 3 means 3 floats, got that? So keeping track, 3 floats. Now, let's put RDI, the 3 float input. Float input. Okay, this is going to be tough. We need three pointers. First number, second number, and third number. Okay, so let's do, man. Okay, let's push. Okay, push. I'm creating space for 3 numbers. Push R Q word 0. Okay, so over here on this, I have to do a picture in parallel to explain it. I got 2 things on the table here. Is this should be in red? Okay, so here's the old stack. We do the first push. And it's all full of 64 little zeros. Okay, RSP is here, but this is available space for us to work with. So we're going to say, there's RSP, move I lost my track, RSI, RSP. Okay, so over here, now we have RSI, both pointing to that empty space. It's not empty, it's full of zeros. Let's push again. This is 0. When we do a push, RSP moves ahead, but RSI is not affected. Okay, so we're going to move RDX, RSP. Okay, so RDX is here. But we need 3 numbers. We need 3 quad words. We only got 2 quad words so far. So did I miss the push in between? Sorry. PUSH, quad word 0. Okay, we're going to repeat it for the 3rd time. Push, quad word 0. And in the picture that says you got extra space here, there's a 0. RSP is now moved to keep up with the pushing. Looks like that. So we'll say move. Who's next? RCX, I believe is the next official one, RSP. So RCX. Looks like that. Now, scanf pays attention to these. Scanf, let's see, which one is it going to go to? Is that the first number entered is going to go here, second number entered here, and third one here. No, that isn't right either. This in sequence, the first is here, second is here. There's a special ordering to these registers. RDI is primary, RSI, RDX, RCX. RDI is already in use. It's busy. So the first number entered goes here, second here, and the third here. Let's do it. It's time to, I need where's my blank paper? So at this point, call scanf. Let's suppose that the user at the keyboard has inputted 5.0, 7.0, and 32.0. That's the length of one side, length of the second side, and number of degrees. Okay, so over here in the picture, 5.0 is according to the next available register. So I'll use red so we can see where it goes. 5.0 is here. And the next register available sends 7.0 here. And then it sends 32.0 here. Okay, it's picked up all 3 of them. Now, remember there's a rule that says by the time you get done with your function at the return statement, the number of pushes must equal the number of pops. There's 3 pushes in a row here. We need to clean those out before we go much further. Let's do it in the right order. Let's get the angle out of there first. Move SD XMM 13, comma, top of stack. Okay, so over here, there's not a bunch of registers. This is XMM 15, XMM 14, XMM 13. And a bunch of others down here. So what we just did was move a 32 into here. Okay, so let's get that 32 off. This class is coming in here, going to throw me out. Okay, let's get it out. Pop RAX, we put it in the garbage collector. And now that officially is not there anymore. RSP is back here. Let's get that one out. Move XMM 14 RSP. Okay, so what just happened was 7.0 is now here. We don't need that 7 anymore. Let's get rid of it. Pop RAX. Let's get the last one out of here before they throw me out of this classroom. That's the 5.0. We're going to put it right here. Here it comes. Move SD XMM 15, RSP. And so we're done with the 5. Let's get it out of the stack. We call that cleaning up the stack. POP RAX. And now the stack pointer has gone back to where it was originally, which was before any of those pushes happened. This has all been removed out of sight, and our 3 numbers are now in registers that belong to floating point registers. They're in the right place where they should be. That all worked just nicely. And in the block. In of block, that's it. The block's name was get 3 numbers from the keyboard. And what did it say? Here was the block's title. Obtain from the user 2 sides, 2 side links, and an angle. I should have said, and store them. We don't want to leave them on the stack. All right. Class, I hope you got something out of this, even if you already did this assignment. But I want you to be caught up with the morning class on Tuesday and Thursday, and you are. We're right on schedule with them. And I'm going to resume this discussion on
Professor?
Thursday. Yes.
Could we see the table real quick? We can't see it right now.
Oh, sure. I think you mean this.
Yeah, that one. Can you go up a little bit or move the paper down? Thank you.
Yeah, okay. This is, I'm sorry, I wasn't showing you, I should have shown you all. As I was pushing and popping over here in the source code, this is what was happening in memory. There were 3 pushes of zeros, and then they got filled by scanf with red ink numbers. And then I took them out one by one and put them over here, first in XMM 13, then 14, then 15. And by the time I took all 3 of them out, the stack was back into the state that it was before this block started. Okay. I don't know if there were people banging on the door a moment ago, but I don't hear any banging. Okay. All right, class. We're going to stop because the physical limits of the clock say it's time to. And now I hope you can digest something and get something good out of all this. We'll resume conceptual material probably in a week from now. But right now, today and Thursday, it's all programming matters. And I hope to then advance to project number 2 and talk about what it has to offer. Okay. Okay. Have a nice afternoon, everybody. Go do some programming. I'll be signing out.